Hey scholars, welcome to this video. We're going to be talking about the binomial theorem. So to start off, I want you to look at this table here. These are the expansions of the binomial x plus 1. So you have x plus 1 squared, cubed, fourth to the fifth. And I want you to try and find the pattern. So this is the actual expansion here. And then of course this is the binomial. And we're wondering what is going to be x plus 1 to the fifth. So look at the coefficients. See if you can find the pattern. Pause the video now and try and write it out on your own. Okay, hopefully you pause the video and try to figure it out. Here is the correct answer. X to the fifth, 5x to the fourth, 10x cubed, 10x squared, 5x, and 1. Now, I'm going to talk about in the next slide what the pattern was, but you probably noticed you really just add. So 1 and 1 makes 2. The outsides are always 1. And then to get the next term in between, you just add the 2 above it. So like 1 plus 2 gives you 3. And then 3 plus 3 gives you 6, so on and so on. So that's how you got this last one. So that pattern is pretty famous. This is what it looks like. It's also called Pascal's triangle, but it helps you to find the next term of the coefficients of the binomial expansion. But the question becomes, how can we compute the next expansion without knowing the one before? So that's where today's lesson comes in. So think about the expansion of the binomial x plus 1 to the fifth. If we write it out, it could be written out like this in kind of the factors, x plus 1 over and over. Now the first term of the expansion is x to the fifth. But how many x's do we need to multiply together to get x to the fifth? Well, obviously we have to multiply 5 together to get x to the fifth. Now if you look over here on the right hand side of this equation, how many x's do we have available? Well, we have 5 available. So the question is, how many different ways can we choose 5 x's to multiply together to give you x to the fifth? Well, that's just 5 choose 5, a combination. And the same thing can be said about 4. So the next term is x to the fourth. We have 5 x's available, but we only need 4 of them to multiply together to give you x to the fourth. So there's 5 choose 4 ways of multiplying the 4 x's together to give you x to the fourth. And then 5 choose 3 for x cubed, 5 choose 2 for x squared, 5 choose 1 for x to the 1, and then the last one is just 1. So this pattern continues, and it will allow you to create a formula. So if we rewrite it to any binomial, x plus a, where a could be, x and a really just stand for whatever's in that place, and we'll go over that more in a bit, where it's to the nth power. The number of ways of getting the first term, x to the n, is n choose n. Number of ways of getting the next term, x to the n minus 1, would be n choose n minus 1. And so you just continue that pattern out, and you get this. Notice that the a term is going in the opposite direction. So the x term starts at x to the n, and a starts at 0. And then the next one, a would be 1, and then x to the n would be x to the n minus 1. So they kind of alternate. We can rewrite that in summation notation in the following way. The sum from r equals 0 to n of n choose n minus r, x to the n minus r, a to the r. And we'll have some more practice with this. If it seems intimidating now, don't worry. When you practice with it, you realize it's not really that bad. Let's try an example. I've written the formula up here in the corner for reference. In this one, we just want to expand this binomial, x plus 3 to the fourth, using our formula. So the first step really is to always write out what you know. Notice x and a are really placeholders here. So in this case, x equals x because we have an x here. But a is actually 3. So I write a equals 3. And then this is to the fourth power, so n equals 4. So we're not going to write r equals something because we're going to write every single term here. But in the next couple problems, we're actually going to write r equals and then whatever r is too. Okay, so we really just plug in here. Wherever there was an n, I put a 4 in the formula. And then I replaced x with, well, x was still x, but I replaced a in the formula with a 3 here. So then we would just write out each and every term. And as you go along, r starts at 0, and then it counts up. So it'd be 1, 2, 3, 4. You only need to go to 4, and then you stop. And then you really just simplify from there. This is kind of all written out already, but each of these things, 4 choose 4, 4 choose 3, you can calculate on Desmos, and you get your values here. But also notice 3 is being squared in the second one, so you get 9, and then cubed, so you get 27, and then to the fourth is 81. So those will also factor in because 4 times 3 gives you 12, 6 times 9, 54, and 4 times 27, 108. So just be really neat with all of your work to make sure you get all the coefficients correct. Okay, let's try this one. What is the coefficient of x cubed y cubed in the expansion of x plus 3y to the 6th? So this one, we don't actually need to write out all the terms. We only are interested in the one when r equals 3, because that's going to give us x to the 3rd. So we write it out. X equals x again in this case, but this time a is actually 3y. So the second term here is 3y. N is to the 6th power because we're raising it to the 6th, and then r here is 3. That's the only one we're interested in. So we're not going to write the whole expansion. We're only going to write when r equals 3. So I plug in, and this time I put a 3 for r. And notice a is actually parentheses 3y cubed. So make sure you don't put the 3 on the outside, but it's all of that is the a term. And then you just really simplify, and this is what you get. 540x cubed, y cubed. So your answer here is actually 540. That's the coefficient. Okay, last example. Find the term independent of x in the expansion of x squared minus 1 over 2x to the 6th. So notice here that x squared and 1 over 2x, when you're multiplying those two terms by each other in the expansion, eventually there's going to be a cancellation. So this 1 divided by x term will cancel out the positive exponent, and you'll get a term without x at all. So the first step is to actually figure out which term that is. So this is a two-part question. First, figure out which term has no x. In other words, what is r when it's just a coefficient or x to the 0. And then after we find that, we'll, like the previous example, actually determine what the term is. Okay, the first thing to recognize is that the term independent of x is going to have an x to the 0 because that would just be a constant. And also keep in mind, we're just looking for r, so we can ignore any coefficients. So we write x is x squared in this example. A here is negative 1 half x, 1 half over x. And then n is 6, and we're looking for r. So you're going to have to remember your exponent rules here, but I wrote it out without the coefficients because the coefficient doesn't matter. We're really just looking for r here. And the next part of this question, we're going to figure out what the coefficient is. But notice I plugged in what x was, and I plugged in, but I left r as a variable. And the same thing here. And then from here to here, I kind of split the 1 over x and the negative 1 half into two things, and I'm going to completely ignore the negative 1 half because it's irrelevant. But notice here you've got x to the 12 minus 2r because this 2 distributes to 6 and negative r. And then you've got x to the negative r because 1 over x is the same thing as x to the negative exponent. So then I would actually add negative r to 12 minus 2r, and I would get x to the 12th minus 3r equals x to 0. These exponents have to equal, so that's why I just do 12 minus 3r equals 0, and you find r equals 4. Now, if that process was really confusing, technically you could just start writing out all the terms and figure out which one eventually cancels, but I think this process is much faster. So now that we know that term, all we have to do is write it out. But remember the x's cancel, so we can skip a little bit here. We don't have to do the whole process because we know the x's are going to cancel. So I'm just going to write this out again just for reference, but now we actually know what r is here. So we plug in some variables. N was 6, r was 4. Again, n was 6, r was 4, and r was 4 here. And we really just simplify. And notice the x squared is going to cancel with this x term. We're still going to have the negative 1 half, so I left that there. But all you got is the 6 choose 2 on the front. And you just simplify that, and you see that your term has to be 15 over 16. Alright y'all, that's it for this video. Go ahead now and try the practice assignment.